Hey everybody, in this video we will have a quick review of writing a polynomial equation, solving by factoring, solving by completing the square, and using synthetic division. So to write a polynomial equation given these roots, what I need to understand is if these are the roots, they're the solutions or the zeros, the x-intercepts of an equation when set equal to 0. So if 2 is a root, then one of the factors when it's set equal to 0 will be x minus 2. And if negative 2 is a root, then one of the factors will be x plus 2. And if 3/5 is a root, then one of the factors will be x minus 3/5. All of that when set equal to 0. So now I can multiply either of these, any set of 2 of these binomials. I think it's going to be easiest to do these two and then deal with the fraction later. So we've got x squared plus 2x minus 2x. Those cancel, which will happen anytime you're multiplying two conjugates, which is the same binomial but one with a minus and one with a plus. And then negative 2 times 2 is negative 4. So then times x minus 3/5 equals 0. So now let's distribute again. X squared times x, that's x cubed. Then negative 3/5 x squared. Then negative 4x. And positive 12/5. Okay, now let's do one more step. We're going to multiply both sides of this entire equation by 5 to cancel out the denominator so we don't have any more fractions. So now when I distribute the 5, I get 5x cubed minus 3x squared minus 20x plus 12 equals 0. Next up, we are going to solve this equation by factoring. The first thing I look for anytime I want to factor is a GCF, a greatest common factor, other than 1, but I don't see that here. So we'll go straight to what we need to multiply and what we need to add to. So we're going to multiply. We're going to find two numbers that multiply to 5 times 6, which is 5 times negative 6, which is negative 30. I need two numbers that multiply to negative 30 and add up to 13. Numbers that multiply to negative 30 and add to 13, I believe that's going to be 15 and negative 2. 15 times negative 2 is negative 30. 15 plus negative 2 is 13. So now what I'm going to do is take this 13x and I'm going to split it up into 15x minus 2x. So I have not changed the value. 15x minus 2x is 13x. I still have the 5x squared and the minus 6 equals 0. Now I'm going to factor by grouping. So in my first group, the GCF is 5x. So I'm going to factor 5x out of both of these terms, and that leaves me with x plus 3. My second group starts just before that next sign, and I need to factor out that sign. So I need to factor out a negative, and the GCF looks like it's going to be 2. And when I factor out a negative 2, I get x plus 3. And then all equals 0. So my factored form is 5x minus 2 times x minus 3, or x plus 3. Equals 0. So now to solve it, I need to know what value of x turns this factor into a 0. So when I multiply it by this, I get 0. And what value of x makes this factor a 0. So when I multiply it by this, I get 0. The easy one is negative 3. If I put a negative 3 here, I get 0 times whatever this turns out to be when I put in a negative 3, and that equals 0. Then I'm going to set this factor equal to 0. 5x minus 2 equals 0. I'll move that over and it becomes a positive 2. Then divide by 5 and I get 2/5. So the other solution is 2/5. So those are my two solutions from factoring. Next up, we are going to solve by completing the square. When we complete the square, the first thing we have to deal with is this lead coefficient. If it's anything other than 1, we need to divide it out of both sides. So I'm dividing both sides by 5, and I get x squared plus 5x plus 7 equals 0. Okay, so now that the lead coefficient is 1, I can complete the square. So I'm going to move this 7 over. So this is the c term. I'm moving that over, x squared plus 5x, and I'm going to leave space for a new c equals, well, I shouldn't have written a 0 there, equals -7, and then a blank for a new c. So now to get that new c, I'm going to take that b, which is 5, divide it by 2, and square it. 5 over 2 squared is 25 over 4, so plus 25 over 4 on both sides. Now I need to factor this. So I've actually done the completing the square part. This is now a square trinomial, and I know that because when I factor it, it's going to come out to some binomial times itself, or a binomial squared. And the easy way to find what goes in here, well, first I've got x, that's my variable. And then it's either plus or it's minus some number, and then squared. Well, that number is whatever I get inside the parentheses here before I square. 5 divided by 2, and that's just 5 over 2, so plus 5 halves equals. Okay, so x plus 5 halves squared is going to equal x squared plus 5x plus 25 fourths. So this is my factored form. Now I need to add these. I could use a calculator, but why use a calculator when we can do this in our heads? If I need a common denominator, and I do, to add or subtract, I could just multiply numerator and denominator here by 4, and that's going to give me -28 over 4 plus 25 over 4. And that is -3 over 4. Next, I need to get rid of this squared, so I'm going to take a square root to cancel that out, and I get x plus 5 halves equals, and this is where my two solutions will come in. When I take the square root, I get plus or minus the square root of -3/4. Okay, so we're going to move this over here, and we're going to simplify the radical. So I get x equals -5 halves plus or minus. The numerator, we'll put that negative in the numerator, -3, so square root of -3 is I times the square root of 3. And in the denominator, the square root of 4 is 2. And that is my solution set. And last, we are going to use synthetic division. These two are to be considered two factors of some bigger polynomial. If I were to multiply these, I'd get a bigger polynomial with these two factors. Now, if this were set equal to 0, then this factor tells me one of the solutions would be -2. So all of this just disappeared because I made a mistake over here, and I need to start over. So I'm going to put a -2 right here, and make a little box like this, sort of a box. And inside of this, I'm going to put all the coefficients. Now, the coefficients are 5x to the 5th, but then I don't have an x to the 4th, so 0x to the 4th, 0x cubed, -3x squared, 0x, and +2. And I'm going to put a little line segment here to split these last two, and this is where my remainder is going to go. Now it's set up, so I'm going to start by bringing down this 5, and then I'm going to multiply. -2 times 5, and then I'm going to add these, 0 and -10. Then I'm going to multiply -2 times -10, and I'm going to add these, 0 and 20. -2 times 20, and then -3 plus -40. Then -2 times -43, and 0 plus 86. And last, -2 times 86, and 2 plus -172. So here's my remainder. Here's my constant term, then my first power, second power, third power, fourth power, which happens to be 1 less than this. It always will be. So I have 5x to the fourth minus 10x cubed plus 20x squared minus 43x plus 86. And then this is negative, so minus 170 over x plus 2.